Hi guys, I hope you're doing well. So let me just finish the second part of the section 13.1, 13.2, 13.3. So it's about the curvature. So again we have a curve. So let's say r of t. Again it's x of t, y of t, z of t. So it's just it's some curve here. Okay, this is r of t is a curve, right? So this is my x, this is my y here, and here's my z. So I have my curves. Anyway, so what's the curvature of a curve? Well, curvature of a curve, actually, it's just it measures by how quickly curve change direction at a point. Okay, so it measures how quickly a curve changes direction at a point. Changes direction at a point. Okay, so for example, so let's say you have here, so we have a straight line. Here we have like a big circle, and here I have a very small circle. Okay, and let's try to guess what will be the curvature. Okay, so you have a straight line. If you have a straight line, of course, you don't change the direction, right? It's always the same direction. You never change the direction on a straight line. So if you never change the direction, so the curvature would be 0 here. Again, because the curvature measure how quickly you change direction at the point, but if you never change direction, so that will be just 0. So the curvature on straight line is just 0. Here, on the big circle, well, if you take a point here, it's kind of flat, but later it's gonna change, a little bit the direction, right? It change a little bit of direction. So if it change a little bit of direction, then the curvature here would be kind of small, because it changed a little bit of direction. And here, and this is very small, on this small circle, if you are at this point, of course, you're gonna change quickly the direction. So in this case, the curvature is gonna be kind of large. It's large. Okay, so again, on a straight line, you don't change the direction, so the curvature will be 0. In very large circles, so if you have at a point here, it looks like a flat, but it's not, because later you're gonna change the direction, but so then the curvature will be small. Okay, because it's gonna take time before changing direction, right? And here you're gonna change the direction very quickly, because it's a very small circle. So then the curvature is gonna be a really large number. Okay. So now, how do we compute the curvature? So we have a formula for that. So formula of the curvature of a curve. So let's say you have a curve r of t, right? That's my curve, r of t. Then let's define capital T to be r prime of t over the length of r prime of t. Okay, then the curvature is going to be equal to the length of capital T prime of t over the length of r prime of t. Okay, so let's do a numerical example. So let's say r of t is just, let's say, 2 cosine of t, 2 sine of t, and then let's say just 0 here. Okay, so it's kind of it's like a helix. So it will be like a kind of helix here. Okay, so that will be my curve, and I want to measure, you know, the curvature. So the question here is to find the curvature of r of t. Find the curvature of r of t. So step one. So what we do first, we need to compute capital T. So in order to compute capital T, first we need r prime of t. So what's r prime of t here? So derivative of cosine is minus sine, so that's minus 2 sine of t, 2 cosine of t, and then 0. Now what's the length of r prime of t? So that would be equal to square root negative 2 sine of t plus 2 cosine of t squared, of course. 2 cosine of t squared plus 0 squared. So that will be equal to, so the length of r prime of t, so that will be equal to 4 cosine squared plus 4 sine squared 4 sine square of t plus 4 cosine square of t. You can factor out 4. So that's square root of 4 sine square plus cosine square. So this is equal to 1, of course. So then r prime of t, the length of r prime of t is square root of 4, which is of course 2. So then capital T, which is r prime of t, over the length of r prime of t. So we're gonna divide. So r prime of t is minus 2 sine, 2 cosine, so it's minus 2 sine, 2 cosine, and 0 over 2. So then you just divide by 2 the 3 coordinates, so it's gonna be minus sine of t, cosine of t, and 0. Okay, so we got our capital T. Now step 2, we can compute the curvature. So the curvature should be the length of capital T prime over the length of r prime of t, right? So that's the curvature. So capital T, we said capital T is minus sine, cosine, and then 0. So it will be capital T prime. So derivative of sine is cosine, so minus cosine, minus sine, and then 0. So the length of capital T prime, so square root of, negative cosine of t squared plus negative sine of t squared. So that's cosine squared plus sine squared, so that's square root of 1, so that's equal to 1. So find the answer. So then the curvature, which is the length of t prime of t. So the length of t prime of t is 1 over the length of r prime of t. So that would be equal to, so we said 1 here. So this is 1 over, and then r prime of t, the length of r prime of t, we said it's equal to 2. So 1 over 2. So the answer is 1/2. So that will be the curvature. So the curvature is equal to 1/2. Okay, guys, yeah, that's it. So for the curvature, I'm gonna stop here. But again, you're gonna find more details in the lecture notes. See you next time. Thanks.